Hi guys, we have here a radio which have some props with sense, so we're gonna check it out and try to fix a problem. Okay, first of all, I connected the radio. It is Yaesu FT747 GX. First I connected the radio to the signal generator, and I'm sending minus 73 dBm into the radio. Minus 73 dBm should reach a S-meter level of about S9. But what we can see here is it is only S3. So okay, that could be misalignment of the S-meter, but it can also be an indication that there is a problem with sense, so that the radio is not really able to receive the signal in a proper way. Okay, therefore we are going to perform a sense test, but first of all, to know what Yaesu is telling us about sense, we have to look into the manual. And okay, what can we find here? We can see in SSB above 1.5 megahertz we should reach at least a signal to noise ratio of 10 dB with input signal input level of 0.25 microvolt. Okay, so let's check what we get. So first of all, we connect a dummy resistor to the external to the external loudspeaker jack. Now the audio frequency is not going to the internal loudspeaker. It is now on this little dummy resistor. It's easily an 8 ohm resistor, and to the 8 ohm resistor I connect my RF voltmeter. I put it here with a croco and ground. Okay, and now I can read the voltage at the resistor. It is 0.73, so that is 73 millivolts. I will increase it a little bit. I increase it a little bit so that I have at least 300 millivolts. Okay. Now I'm switching to my signal to noise signal with minus 73 dBm injected signal. We find 37 signal to noise ratio, which is nice, but we would like to check against the Yaesu measurement, which was telling us 10 dB and 10 dB signal to noise ratio with 0.25 microvolts. Okay, so I'm telling 10 dB and signal to noise. Now the generator is reducing the injected RF level until 10 dB is reached. What we find is that 10 dB is reached with 100 and minus 102.5 dBm. We have to convert it. We have to convert it to microvolts, and what we can find, minus 102 microvolt, minus 102 dBm means 1.8 microvolt to reach the 10 dB signal to noise ratio. So that is much more what we need as RF level to get at least the 10 dB signal to noise ratio. So that means sense is not finally okay, and well, what is Yaesu telling us? They say 0.5 microvolt. Some reflections here. 0.5 microvolts, 0.25 microvolts is what the radio should be able to get. So that is much lower to reach already the 10 dB signal to noise ratio. That is much lower what we have measured right now. So we measured, just to remember, 102 minus 102.5 dBm to reach at least 10 dB signal to noise, and minus 102 is 1.8 microvolt. So that is definitely, there we have definitely a problem with sense. Good. So what we know is that somewhere in the receiver track must be a problem, so that can be a fault, so maybe a shorted transistor or whatever, or a bad connection, or it is simply a bad alignment, which can happen after a couple of years. I mean, the Yaesu FT747 GX is 20 plus years old, and so that is a couple of years, and that means maybe some of the alignments could be bad after that period of time, or another it is really an issue. Some guys trying to turn the coils and they think they can improve the radio, but without proper equipment it is absolutely not possible, and so they're doing worse, and at the end of the day, you know, they have a bad receiver, and well, so we have to check it out. So the first thing is we are going to perform a new alignment, and that will follow in the second little video. We will close down the first part, so just to summarize what we know. Our sense is definitely bad, so we need more RF level to reach at least the 10 dB signal to noise ratio. So that is what we can see here, and this is the signal to noise ratio. So we really need to check out where the problem is, and next video we will leach the system, and we will see whether we can improve the receiver condition to at minimum what Yaesu is writing down in the specs. Okay, thank you.